The aim of this video is to provide you with some strategies and methods to help you design PLC programs using ladder diagram and function block programming languages. Start with the program specifications provided. Identify what the program is trying to achieve. Identify the input and output requirements. Divide the job into a series of smaller jobs dealing with one section of the program at a time. Select a suitable PLC from the manufacturer's catalogue. We want a program that will monitor the condition of 3 pumps. So we aren't controlling the pumps but monitoring them. Let's say that it could be part of a larger program and we have divided that job into sections and now we are working on this section. The program will use variable names that relate to the drawings to simplify tracing problems. There are 4 digital inputs. We have a digital input called aux-X, that is an auxiliary contact off the pump X contactor. There are another 3 digital inputs, one for each pump to indicate that it is running. Pump X CT, pump Y CT, and pump Z CT. There are 3 digital outputs. The first is fault to indicate when pump X is in a fault condition. The next 2 are code bits that can indicate how many pumps are running. Divide the whole project into a series of smaller tasks by dealing with one output at a time. Start with the outputs and work back to the inputs by deciding what has to happen for the output to come on. Output 1 comes on when the pump X is in fault, and there is an auxiliary X to tell us when the pump is switched on, and pump X CT to indicate that pump X is running. You can use a written English sentence to describe the operation and from that sentence determine what the program will look like. The nouns are the required points and are the inputs and outputs. The conjunctions like and or describe how they are connected together. And means the inputs are in series and or means the inputs are in parallel. There is an auxiliary X to indicate when the pump X is switched on, and pump X CT indicates that pump X is running correctly. We can use a truth table to show the possible combinations. If the auxiliary X is off and pump X CT is off, then this isn't a fault. We show a 0. If auxiliary X is off and pump X CT is on, then this is a fault. We show a 1. If auxiliary X is on and pump X CT is off, then this is a fault. We'll show a 1. If auxiliary X is on and pump X CT is on, then this isn't a fault. We show a 0. Fault is on when auxiliary X or pump CT is on, but not both. You may recognize this truth table as the one for the exclusive OR. We can still go through the exercise of developing the program. We can have a look at this sentence. Both means auxiliary X and pump XCT. So not both will mean not auxiliary and pump XCT. We can now rewrite our sentence to be on when auxiliary X or pump XCT and not auxiliary X and pump XCT. We can group it together so it looks a bit simpler and use the brackets to isolate the sections. Start with the first brackets, auxiliary X or pump XCT, and we can use an internal relay which we will call R1. So R1 equals auxiliary X or pump XCT. Next is the second set of brackets, auxiliary X and pump XCT, and we can use another internal relay which we will call R2. So R2 equals auxiliary X and pump XCT. We can rewrite our sentence to substitute R1 and R2. The AND means that they are in series, and NOT means that we invert R2. Now we can bring it all together and show our 3 lines of code. The next step is to test if our program truth table is the same as the one we want. Both inputs are off and the fault indicator is off. Auxiliary X is off and pump XCT is on, and the fault indicator is on. Auxiliary X is on and pump XCT is off, and the fault indicator is on. Both inputs are on and the fault indicator is off. The truth table is the same, so the program we have made works. Here is the function block version, and we can step through its function and prove that the truth table is correct. There are no internal relays. That function is performed by the interconnections between the function blocks. Both inputs are off and the fault indicator is off. Auxiliary X is off and pump XCT is on, and the fault indicator is on. Auxiliary X is on and pump XCT is off, and the fault indicator is on. Both inputs are on and the fault indicator is off. The truth table is the same, so the program we have made works. With this method, we can use the truth table to design our program. Focus on the conditions when the output is on. There are 2 that are true. Fault is on if line 2 is true or line 3 is true. For line 2, fault is on if auxiliary is not on and pump XCT is on. If we use the normally closed auxiliary X and the normally open pump XCT, then this line will be true. This will only work for the condition when auxiliary X is off and pump XCT is on. We need to include the condition for line 3. For line 3, fault is on if auxiliary is on and pump CT is not on. If we use the normally open auxiliary X and the normally closed pump XCT, then this line will be true. This will only work for the condition when auxiliary X is on and pump XCT is off. We need to combine both lines with the OR. Fault is on if line 2 is true or line 3 is true. Now test the program against the desired truth table. Both inputs are off and the fault indicator is off. Auxiliary X is off and pump XCT is on, and the fault indicator is on. Auxiliary X is on and pump XCT is off, and the fault indicator is on. Both inputs are on and the fault indicator is off. The truth table is the same, so the program we have made works. Use the Zelio Soft PLC program to test the programs that we have written for yourself. Do all the different versions of the same program all perform the same function? Try the exclusive OR function. Does it work the same as all the other programs developed? The next step is to look at the code bits. We need to program the 2 code bits so that they indicate how many pumps are running. Firstly, let's have a look at how these 2 outputs work together so we can separate them. This table shows how we can use 2 bits to show how many pumps are running. The output code 1 comes on when 1 pump or 3 pumps are running. The output code 2 comes on when 2 pumps or 3 pumps are running. Note that we are not specifying which pumps, just the number. All possible combinations need to be catered for. We can create 3 internal relays called 1 pump, 2 pumps, 3 pumps. We are still dividing our job into smaller jobs, so let's start with 1 pump. Make a truth table showing all the possible combinations of pumps, and we can see what the combinations are. Earlier on, the variable R1 was created, which comes on when auxiliary X and pump XCT are on. So R1 will be used instead of pump XCT alone because R1 contains more information. Look at the truth table and identify the conditions where one pump is on and the other two are off. So we want the lines where there are a combination of 2 zeros and 1 1. All the other combinations are either 2 or 3 pumps. We want line 2 or line 3 or line 5. Line 2 is true if pump Z is not on and pump Y is not on and pump X is on. We can specify the conditions for the other 2 lines. So we have line 2 or line 3 or line 5. This is the ladder diagram for the one pump internal relay. It consists of an OR function made up with 3 lines that match the 3 possibilities of only one pump running. The next step is to create the 3 pump internal relay. We want an internal relay that indicates when all 3 pumps are running. Identify which lines of the truth table are true for all 3 pumps running. There is only one line that shows all pumps running, and this is the bottom line. So pump 3 is on if pump Z is on and pump Y is on and R1 is on. Here is the program for 3 pumps and consists of a single AND function of pump XCT and pump YCT and R1. Code 1 comes on if there are 1 pump or 3 pumps running. This is the final part of the program where we combine 1 pump and 3 pump variables with the OR function to operate the code 1 output. We can now put it all together to show the complete program for turning on the code 1 output. The next section to develop is the code 2 output. Code 2 comes on if there are 2 pumps or 3 pumps running. We need an internal relay for 2 pumps. Here is the truth table showing all the combinations of pumps running. Identify which ones occur for 2 pumps running. Go ahead and produce the program for 2 pumps relay. Combine the 2 pumps and the 3 pumps relays to turn on the code 2 output. The final part is to combine all the outputs into the program and test that it works as expected. Refer to the workbook for the final program. Convert the program to function block and test. We have identified the specifications of the program. We have divided the program into sections based on the outputs to simplify the designing of the project. Each output was divided into sections by creating internal relays. Programming was done using truth tables and sentences. Programming was done using function block and ladder.